Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks for Geeks problem of the day, and today's problem is min time and it is a medium level problem. So I believe after a very long time, I encountered a good problem on Geeks for Geeks. You can again reduce this problem into a standard DP problem, but still I would like to appreciate the Geeks for Geeks team to give such an interesting problem, because this problem was a little bit different from the problems that we were getting these days, and it's very good to see such problems. So let us quickly start with the problem description. Now they say we have been given two arrays, locations and types, right? So type of I will be denoting the type of the ith fruit, and location of I will be denoting the location of the ith fruit. Now our task is to collect those fruits, and our only constraint is that we have to collect them in non-decreasing order of their types, right? So that means all the fruits that are of type X should be collected before all the fruits that are of type X plus 1. So for example, in this particular case, you will see there is a fruit of type 1, fruit of type 2, fruit of type 3, and again a fruit of type 1. So if you want to pick a fruit of type 2, then it is necessary for you to pick all the fruits of type 1 first, right? This is our only constraint, and among all the fruits of type 1, you can pick them in any order, right? So it's basically like you have to minimize the time to collect all the fruits. And what is time? So if there are 2 points x and y, the time taken to travel between x and y is modulo of x minus y, or like the absolute value of x minus y. So let me just explain you with the help of this particular sample test case first, and we'll discuss what they're trying to say here. So this is our sample test case. So let us first have the locations, and they are 1, 3, 5 and 7. So if I try to draw a number line, right, so I have a number line here. So there is a point 1, there is a point 2, there is a point 3, 4, 5, 6 and 7. So there are some fruits present at position 1, so it is of type 1. Now at position 3 it is of type 2. Now at position 5 it is of type 3. Now at position 7 it is of type 1. And also there is one very important thing that I forgot to mention, that you have to start and end at the coordinate 0, right? So you have to start from this particular position and end at this particular position only, right? So what we do is, they say that we start from point x is equals to 0 and move to 7. So if we move from here to here, right, you will see I'll be able to collect this fruit during my path from first to last position, and then I'll be able to collect this particular fruit, right? I cannot collect fruit T2 and T3 because they are of type 2 and 3 respectively. So I haven't collected all fruits of type 1, hence I cannot collect them first. So I come to position 7, my total distance traveled is 7, and I've collected all fruits of type 1. Now I can go back to this particular position to collect fruit of type 2. Now the difference between 7 and 3 is 4, so I have to add 4 to my answer, right? Now again I go to collect fruit of type 3. Now this particular distance is 2, so I'll have to add 2 to my answer. Now I am at position 5, and remember we have to return to position 0. So this total distance is 5, so the total time taken in this particular case is 18, right? This is how they are trying to find the answer. Now let us discuss some interesting properties about how this particular question is laid out. So let me just again draw a number line. So if I have a number line like this, right, now let us consider there are some fruits of same type, right? So this is position x1, this is position x2, this is position x3, this is position x4, x5, and so on up to, let's say you have xn, right? So let's assume that these are all fruits of same type laid out at positions x1, x2, x3, x4, x5 and so on up to xn. So now there is a very interesting observation from here, that I only need to take a fruit at position x1 and fruit at position xn. Why is this true? So let's say your initial starting point was somewhere right here, right, to the left of all the fruits, right? So you take fruit x1 first, so you take this particular fruit, good enough. Now you try to take fruit xn, right? So you go to x1 first and then you go to xn, and you will realize that you have covered all fruits in between, right? So if you try to take x1 first and then xn, then you would have covered all the fruits in between. Or even if you go to xn first and then again come back to x1, although it is not necessary, because in any ways you would have already taken all the fruits. But let's say you go to xn first and then come to x1, then again you would have taken all the fruits in this particular process, right? So now let me just take some other position. So let's say you were somewhere in between, right? Again the same analogy applies, that you can go to x1 and then you can go to xn, right? So you will cover all these fruits while going to from x4 to x1, and these two fruits while going from x1 to xn, right? So again you can also do the reverse. You can go to xn first, like this. You can go to xn first, and from xn you can go to x1, right? So you see, I'm just trying to consider only 2 points, that is the first point, minimum point, and the maximum point on the number line for that particular type, right? Again, if I am at the last position, I can go to xn first and then go to x1, or I can even go to x1 first and then come back to xn. It really doesn't matter, right? So again, I have covered all the points, but obviously my task is to minimize my time. How can I try to minimize it? So let's say if I am at some point here and I am at some point here, right? For these 2 points, the answer is always going to be the same, right? So the answer is going to be the distance between the farthest point. So starting from this particular point to this particular point, this is going to be the distance if I am starting from left to all the elements, and if I am starting from right to all the elements, the answer will be the distance between this point and x1, right? So this is how we can find an answer. But there is a problem with this approach. What happens? What happens if my element is in between, right? So my element x is somewhere in between. Then I have to go to one side and then go back to the other side, right? So you will see I will be repeating this part, right? I'll be repeating this part because this path I have traveled once and this path I have traveled twice while coming back to here, and this path I have already traveled once. So the path I am traveling twice, I would want to reduce this path if I have a point x. So if the distance of x1 minus x is less than xn minus x, obviously this is the modular value, the absolute value. If this is true, then you will go to x1 first, otherwise you will go to xn first, right? But again, there is a problem with this approach. So like with all this lengthy explanation, all I am trying to tell you is what is the thought process that you need to go while solving such problems. So till now we have figured out that there are only 2 important points that we need to consider, right? We have figured out different cases. What if the starting point was to the left of all the points? What if the starting point was to the right of all the points? And what if the starting point was at the middle of all the points? So during the last point, when the starting point was in the middle, we discovered this particular scenario. If the first distance is less than the second distance, then we will visit x1 first and then we will visit xn. Otherwise, we will visit xn first and then visit x1. But the problem with this approach is, for example, if there is a let's say these elements were all of type 1. Now there is an element of type 2, right? So this distance was smaller. Let's say this is dx and this distance was smaller. So I visited x1 first and then xn. Now the element of type 2 is somewhere here to the left of it, right? So if I go to x1 first and then go to xn and then go to this particular point again, so this is obviously going to be a repetition. So basically I am going from this point to this point and then this point to xn and then again xn to go back here, right? So this is a lot of repetition and I would obviously not want that particular thing. So how do I optimize this problem further? Now let us discuss the most optimal solution for this particular problem, and that is using dynamic programming. So I have told you why greedy won't work. We have tried to form a greedy solution. We also tried to think, if we try to implement greedy, how can we actually implement it? But we realized quickly that this is obviously going to fail under certain circumstances. So how can we reduce it to a DP problem? So let me just draw an array first. So if I have an array like this, right? So let's say we have some elements These elements are of type 1, type 2, type 3, type 4, type 5 and type 6, right. So let 0 denote the minimum index of type 1 and 1 denote the maximum index of type 1, right. So this is the leftmost index and this is the rightmost index. So let's say this is some x10, this is x11, this is x20, x21, x30, x31, x40, x41. Let me just write it till here only. So you will observe that if you're trying to form your answer, what you can do is either you can start from this particular point and go to this point first, right, or you can start from this particular point and go to this point, or you can start from this particular point and go to this point, or the last option is start from this particular point and go to this point. So at each stage I have only 4 choices, right. At each stage I will have only 4 choices. Let's say I am at the current index of type 2, I am trying to start with the minimum index. So there are 2 choices, that either I would have ended with the minimum index of previous type or I would have ended with the maximum index of previous type, right. So I can calculate my best answer for starting with this particular type from the previous type. So if I have ended at the minimum index, then I will try to go from here, and then from here I will go to this particular index. So I believe like this is getting a little bit complex. So let me just denote it on a number line. So let's say I have a number line like this, right. Let's say these are some elements of type 1 and let's say these are some elements of type 2. So since I'm only considered about the endpoints, the minimum and the maximum, I can remove these points from the number line, right. Now let's say you ended the previous type at this particular index, the last index. Now from here you can either go here or you can go here, right. Going here means go here first. Anyways you will have to visit both of the points, right, because we discussed it is necessary to visit both of the points if you want to cover all the points in between. But all I'm saying is you go at this particular point here first and then from here you go here, or you can go to this particular point first and then you go from here to here, right. So you see, it is not about choosing one point, it is about choosing the first point and then from that particular point going to the second point, right. The other option is, if I just erase all of this, the other option is you ended, remember you ended the previous iteration here, right. Now from this particular point you can go to this particular point and then the ending, or you can go to this particular point first and then the beginning, right. So these are 2 different things. So here I am deciding to which element I should go first, and here I am deciding which element did I go to second. Because if I started with this particular element, then I go here and then from here I can choose whether I want to start with this particular element or this particular element, right. So what will our DP will look like? So my DP is going to be a 2-dimensional array, DP of ij, right, and this denotes, i's denote the current type, and j, if j is equals to 0, it is denoting at current type I start with the minimum position and then go to max position, right. So you see that this is very important. I start with the minimum position and then I go to the maximum position. It is not that I am just choosing the minimum position, it's just that I am starting with the minimum position and then I will definitely go to the maximum position. It is very important for me to take both of the positions. Now let's say j is equals to 1, at current type I, I start with the maximum position and then go to minimum position, right. So it is very important you to realize this particular fact, that I am not choosing which one of the positions to pick, I am just choosing which one of the positions to start with, right. So I have written this part out. Now let me just take the code so that I can explain you with the help of the code. So I'm just quickly going to take this particular part. I believe like this way it is easier to explain you. So I'll just have it here. So I discussed that we will have 4 cases, and now you can see this code in accordance to this particular thing that I have written above. So dp of I0, right? So I means the current type and this 0 means that I am taking the minimum of the current type, and I am considering a case where I am taking the minimum of the last type as well. So I have added comments for better readability, and it was really helpful for me as well. So you see I am taking the current minimum and the last type minimum as well. So if I take the last type minimum, remember what do I mean by last type minimum? Last type minimum means I started with the minimum number when I was at I minus 1 position, right? So if I started with the minimum number, that means I would have ended with the maximum index. So let's say in this particular diagram, let me just quickly erase this all of this stuff. So you see that I started with the minimum index, that is this particular index. If I started with this index, then I would have definitely got to this particular index, right? So dp of I minus 1 and 0 is denoting that I started with the minimum index. This is the cost for it. Now, since I started with the minimum index, that means I would have ended here, right? So I need to take the absolute difference of v of I minus 1, that is the maximum index. And from this particular position, I want to go to the minimum index of the next type, right? So from this particular position, I am going to this particular position. This is what I have written here in this particular part, right? Now, from this starting minimum position, I need to go to this max position. So again, from this current starting position, I go to the current maximum position, right? Now let us discuss the second type, taking the current minimum and last maximum. So that means I am taking the current minimum same as earlier. So this time I am going to take the minimum value of dp of I0 because I have already set some value in dp of I0 already, right? So I need to take the minimum value. I am taking the maximum value from the last type. Taking the maximum value means I started with the maximum value during the previous type. So dp of I minus 1. This time you will see that I started with the maximum value. So if I started with the maximum value, that means I started from here. Then I would have gone to here, right? Now since I am taking the minimum value, right, this time, so I will take the distance from this particular point to this particular point. So this is, you will see that this is exactly what I am taking. V of I minus 1, 0 and V of I0. So this is V of I minus 1, 0 and this is V of I0, right? And then again the same thing as previously, the difference between the current maximum and current minimum, right? Now let us discuss the next case where during the current type I took the maximum and during the previous type I took the minimum. So current type taking the maximum as dp of I1. Last time I took the minimum as dp of I minus 1, 0, and then if I took last time the minimum first, then I would have definitely ended at the last position. So last time if I took the minimum first, that is this particular one, then I would have ended at this particular position. Now I need to take the distance between this point and this point, since I am taking the maximum position now. So it should be v of I minus 1 minus v of I1. Right. So you will see this is exactly that should be here, v of I minus 1 and v of I1. So it is not just some random thing I have written. All of it has a logic and it is a reason why it works. And I'm already trying to explain you all of this with the help of a diagram, because like if you think it in terms of number line, it is much easier to understand. And that is why I showed you this code first, because if I just keep on explaining it, it would never be helpful. So now I need to also consider this particular part, because if I have come to this particular position, I also need to go back here, right? And similarly, the last part, taking the current type maximum and last type maximum. So dp of I1, since I have already calculated dp of I1 before here, so this time I need to take the minimum value, because dp of I1 must be having some value earlier and I am computing some new value as well. So what is this value? Since I am taking the last type maximum, that is dp of I minus 1, right? Now since I have taken the last type maximum first, that means if I took the maximum, I would have gone to minimum to end it, right? That would be at v of I minus 1, 0. Now from here I need to go to the current maximum, that is v of I1, and if I have gone to v of I1, I need to go back to v of I0. This is the last part, right? So this is all you had to do. If you do all of this stuff, then your code will work, and this is all the types that you have in between, right? So let's say this is of type 2, type 3, type 7, and some type 10, and let's say 12, right? So you for all of them you had some minimum and maximum value. Now this is our V array, right? This is different from what was given to us in the input. Now one important thing, since you want to start from 0, so you can just write 0 0, append 0 0 in front of it, and since you want to end at like 0 0, so you can write 0 0 at the end of it, right? So this can be some minimum value, this can be some maximum value, and so on for each of the types, but at the beginning you can append 0 0, and at the end you can append 0 0 as well, because you want to start from 0 and end at 0, right? So if you do this, like this particular DP for loop will take care of all the other things. And let me just show you the final code, what is happening here. So let us discuss the remaining part. A lot of it I have already discussed. Let us discuss the remaining part. I'm not going to discuss this part again, and let's see what preparation we have to do in order to execute this part. So what I'm doing basically is I'm creating a map. So what I'm trying to do in this particular map is I'm trying to differentiate these locations with respect to their types, right? Now you might argue that I'm using a map, it's n log n, and it's definitely not the complexity that we are expecting here, right? So it's O of n. So what I would like to say is that in this particular thing, we are trying to differentiate the locations with respect to the types. Now the types is only up to 10 raised to power 5, so you can always apply some other method to differentiate it with respect to the types. But I just found it to be more convenient, and I tried to focus on the main logic of this problem. So that is why I implemented a map. Otherwise, I leave it as a task for you to do this particular part in O of n also. But even if you leave it like this, there's no problem. It should still work. And this is just one thing I wanted to mention, right? So other than this, the complexity will be O of n really, because we have one for loop here, right? So let us say that what we're trying to do here is, if my type already exists in my map, then I'll update my map of 0 as for that particular type as minimum of the already existing value and locations of I. Otherwise, for the first value, I'll update it as maximum value, right? So 0 will be containing the minimum value and 1 will be containing the maximum value. If it doesn't exist, that means if I'm not able to find it in my map, I just push back locations of I itself at that particular type, right? So now I have all the types in my map, right? And I have removed all the redundant values. Now I create a vector v. So this is the vector v that we were using in the DP, and I create a smaller vector of 2 dimensions. It is 0 and 0. So I was not able to directly push back this 0 0 into the vector v. So that is why I have to create this, and I just push back 0 into my vector v. So I told you that we need to push back 0 0 in the beginning and 0 0 at the end, right? So I just traverse to the map after pushing this 0 0, and I just push all the vectors in my vector v. So now you see that as long as we have all the types sorted, it doesn't really matter what is the type number, it is 0, 1, 2, 3 or whatever. It's just that they should be in some order, right? So you see that I'm only concerned about the minimum and the maximum value, and I'm not concerned about the types anymore, because my map would have already sorted them, right? Now if I have pushed all these values, now I push back the 0 vector again into my final vector, and I'll update my value of n. Since this value, the previous value of n was no longer required, I just use this value again. You can use some other value as well, and I created a 2-dimensional DP vector of size n cross 2, right? And now from here on, I have already explained what is the answer, and I have like returned DP of n minus 1 0. So you could have also returned DP of n minus 1 1. It should still work, and I can just write it 1 here, because at the last position you are having 0 0 at both of the zeros and ones. So it doesn't matter which one of those you visit, you can just return any of them, right? So let me just quickly submit this code and show you that this works. And I know like this particular explanation was a bit long, and I hope that you guys were able to understand it, because this was quite an interesting problem. You see that it passes all the test cases, and yeah, this was all about today's video. Just you just have to make sure that you don't make any mistakes in this particular part, because like that is why I have included comments, so that I don't forget and I don't make any mistakes. Just have to be careful in this particular part. Otherwise, this was an interesting question, and don't worry if you had some problems in solving it. It's totally normal. And that's it for today. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to subscribe to this channel. It's always free of cost, and you can always subscribe later if you don't find the videos interesting. Drop a like and share your thoughts in the comments what you felt about today's problem, because your engagement with this particular video really helps the YouTube algorithm to understand that this video was actually helpful for you, and it will be able to reach more number of people like you who want to keep solving new problems. So till the next video drops, keep coding, stay safe, bye bye.